Alright guys, this is solving absolute value inequalities intro. The first part of it, it's just so that you kind of get the concept of what we're doing, and then I'm just going to give you some steps on how to solve it. These can get kind of confusing, so you want to kind of make sure that you're following the steps through pretty well and really kind of internalizing what it is that absolute value means. So remember that absolute value is the distance from 0, which means that it can't be negative. Okay, and then just like absolute value equations, you're normally going to have like two solutions. You still have your special cases and stuff like that. With the inequalities, just here, it's going to look a little bit different. So just remember that the absolute value of something cannot be negative, and you're going to have multiple solutions in some cases. Another thing that you need to remember when you're dealing with inequalities is that when you multiply or divide by a negative, you switch your inequality sign, so it flips the other way. Just a reminder, when you're dealing with greater than or less than, you have an open circle on your number line, and when you have greater than or equal to and less than or equal to, you have a closed circle on your number line. So that's a review there. If this is confusing to you, like if you don't know what numbers lines are or these inequality signs, you need to come see me so that I can break this down a little bit more for you before you even get started here. So in my first example, I have the absolute value of x is less than 12. So one way that you can kind of think about it is what this is asking you is what is less than 12 units away from 0. Now remember, distance isn't negative or positive, it's just kind of the distance that you walk. So if you start here at 0 and you're talking about less than 12 units, well, to the right we have a 12, so less than 12 units would be from 0 to 12. But if you started at 0 and moved to the left, that would also be 12 units. You can move 12 units in either direction. There's 12 units here, and there's 12 units here. Okay, so that's kind of what we're talking about. Now, it's saying what is less than 12 units away? Well, if we started here at 0 and moved to the right, less than 12 units would be, from here in towards 0. Or if we walked out to the left, less than 12 units away from 0 would be starting here at 12 moving in, right? Because this is less than 12 units. If I pick a number here in the middle, it's going to be like 6 or something. So 6 is less than 12 units away from 0. So that's kind of what we're getting at. So here we have, like two inequalities. We can move to the left or to the right. So if I wanted to evaluate the right-hand side over here, well, x less than this side over here can be represented as x less than 12. That's going to be starting at 0 and moving to the right over here. If I wanted to evaluate the left-hand side, you have to remember that on a number line, this is still negative 12. That number there is negative 12, which is 12 units away. So if I wanted to evaluate the left-hand side, I could say, well, x is less than 12, but x is also greater than negative 12, right? That's going to evaluate this here because I have negative 12. So if I wanted to do less than 12 units, that's from here to 12. Well, less than 12 units, could be like negative 6, but negative 6 is actually greater than negative 12. So I have two values here. So x greater than negative 12 and x less than 12. So if I wanted to write this on a number line, it would look kind of like what we have here. We have a less than sign, which is, open circle. So you would have an open circle here at 12, and it moves, x less than 12 is going to move to the left this way. And x greater than negative 12, open circle, is going to move to the right this way. And this is actually going to connect here. So if we're looking for the absolute value of 12, absolute value of x less than 12, well, it's any number in between this interval here, between negative 12 and 12. As we get into solving equations or solving these inequalities, it's going to be a little more complicated, but with some steps that I show you. It shouldn't be too bad. So we're going to be looking at intervals, solution intervals that you could have, or solution sets. My next example that I have for you here is the absolute value of 7x greater than or equal to 21. So what we're asking you, what numbers are greater than or equal to 21 units away from 0? So we're not even going to worry about this 7x on the inside. You know, we know the absolute value of something is greater than or equal to 21 units away from 0. So greater than, when you think about it, greater than or equal to 21 units away, it's going to be further. So 21 units further away. Okay, so going further out. So if you're thinking further away, you know, you're going further out to the right or further out to the left in either direction. So let's kind of think about that. If I plot, 21 here. So there's 21 units away from 0 to the right, 21 units away from 0 to the left. On a number line, this needs to be represented as negative 21 because it represents direction to the left. Okay, so we're kind of asking, okay, what numbers, what values are more than 21 units away from 0 or further than 21 units away? So, you know, we're kind of thinking about, okay, what numbers are coming out this way? So we kind of have two different scenarios here. We need to have an inequality that represents all the numbers further away to the right, and we also need to have an inequality that represents all the numbers further away from 21 on the left-hand side. So you're going to have to write two inequalities here for each of these sections. So if I write an inequality over here to represent that, remember we still have 7x over here. So it would be, what number could I plug in here for x? That would be 21 units or more away from 0. So if we're moving more than 21 or equal to, you know, this number has to be greater than, because if we're moving to the right, it has to be greater than or equal to 21 units away. If I'm looking at this side, I can say, what number can I plug in here for x that is going to move me more than 21 units away from 0? So as we move this way, we're, in terms of the number line, we're moving to the left. And as we move to the left, that's always going to be less than or equal to 21, right? Because we have to move out this way, negative 21. So I have 7x greater than or equal to 21, which looks just like what we have here. And then here, I have 7x less than or equal to negative 21 because we're moving to the left on the negative side here. So now I have two different inequalities that I can go ahead and solve for x. So if I wanted to solve this one here, I have 7x less than or equal to negative 21. Divide each side by 7. That's going to go to 1, so that I have x less than or equal to negative 3. Okay, so there's one solution that I could plot. I have a negative 3 is going to be over here, less than or equal to is closed circle, and less than or equal to is to the right. Okay, so that way. If I come over here to solve the other one on the right, divide this by 7 on each side, x is going to be greater than or equal to a positive 3 over here. So I have two solution sets that would satisfy this absolute value inequality here. So closed circle here, greater than is to the right. So any value for x, oops, sorry, this should have been at 3. Any value that I pick greater than positive 3 or less than negative 3 would satisfy this inequality, which means that it would put me more than 21 units away from 0. Okay, so that's a little complicated. That's fine if it kind of confuses you. What you need to know here are these steps for solving absolute value inequalities. So when you're solving these, the first thing you need to do is solve for the absolute value part. And what I mean by that is I mean for whatever's inside of the absolute value over here. I can't have anything out here. I can't have a 3 being multiplied. I can't have a plus 2, nothing on the outside. We need to get this by itself. Then you need to check for a negative constant. So what that means is that your absolute value can't be negative. Okay, so if you have something like the absolute value of 3x is greater than a negative number, that's okay. That's going to be a true statement because you're going to have a positive number is greater than a negative. Yeah, that's fine. But if you have the absolute value of 3x is less than a negative number, that's not okay. Okay, you can't have a positive less than a negative. That's a false statement. Okay, so that's what you need to look for. You can't have any false statements here. You can't have, an absolute value is less than a negative. You can't have an absolute value is equal to a negative. That's just, by definition, the absolute value is going to be positive there. So you have to check for that. You also need to write two new inequality statements, one for moving in the negative direction and one for moving in the positive direction. So in the positive direction, so you have one positive inequality, it's going to stay exactly the same. So it stays the same as the original part that you've solved for. But then you also have a negative side. Two changes are going to happen there. You're going to flip the inequality sign, and then your constant becomes negative. So you flip the inequality sign, and then you have to change the sign on the constant. And the constant's just whatever number is out here, okay? And I'll go over that with some examples. The last thing you're going to do is you're going to solve and plot each solution, okay? So make sure that you write this down and have this with you as we go through the rest of the examples. So I have this example here. The absolute value v over 7 is less than or equal to 2. So here are our steps. Solve for your absolute value, which we did. Nothing on the left, nothing on the right. Check for the negative or your true statement. So can I have a positive less than or equal to a positive? Sure. Okay, that's a true statement. You can have 1 less than or equal to 2. Okay, so that's like an example there. Okay, so that would be okay. So now we're going to write our inequalities. You have one positive and one negative. The positive one stays the same. V over 7 is less than or equal to 2. The negative one, you flip the inequality sign and then change the sign over here. So this is v over 7 is going to be greater than or equal to what is now negative 2. Now we can go ahead and solve those inequalities. So here on the left, I would multiply both sides by 7 to get rid of that fraction. Here they're going to go to 1. So you have v is less than or equal to 14. There's one inequality. 14 is over here on the positive side. It's going to be closed circle. Less than is to the left. Then we go about to solve the second one. And you're going to follow the same order of operations to solve these on both sides. I need to get rid of that fraction, so times 7 on each side. Here they're going to go to 1. V is greater than or equal to, here I have negative 2 times 7, which is negative 14. Okay, so over here I have negative 14, close circle, greater than or equal to is going to be to the right. So your solution set here is actually going to be any number in between these 2 points, between negative 14 and 14. And one way you can write it is, kind of like when we were writing our domain and range as an inequality, v less than or equal to 14, but greater than or equal to negative 14. Or if you wanted to write it in interval notation, you could as well. Okay, so these are your solution sets here. They're all the same thing. Okay, a few more examples for you. I have 3x, the absolute value of 3x is less than or equal to negative 18. So step 1, solve for the absolute value. It's done. 2, now this is where it's important, where you check for a negative or your true statement. So remember, your absolute value has to be positive, okay, less than. And here we have a negative. Can you have a positive less than a negative? No, that's not true. That's a false statement. So when you have a false statement, something like this, you actually have no solution. Okay, and this is what I mean where you need to check for the negative, all right? Always make sure that you do that here. I'm going to rewrite this example real quick. 2 minus. Okay, so I have one more example for you right here. Step 1 is to solve for our absolute value part. So here it's not, we have not solved for it. We have x plus 1 is inside the absolute value, and we have a 2 minus this whole thing. So before we even do anything, we have to solve for what's inside of here. So let's go ahead and do that. Okay, so I'm just going to rewrite it. 2 minus the absolute value of x plus 1 is greater than negative 4. Now, this is a negative, but we're not going to worry about it yet until this is by itself. That's why it's step 2. So when you're solving for the inequalities, you're always going to work from the outside. So we have to get rid of this 2 over here. So the first thing we're going to do is subtract that 2 on each side. Okay, this whole thing, it's just going to come down. Okay, so 2 minus 2 is 0, and then this negative absolute value of x plus 1 is going to come down. Greater than stays the same. Negative 4 minus 2 is negative 6. So I'm just going to rewrite it. Negative absolute value x plus 1 greater than negative 6. Now we haven't solved for the absolute value part yet. We still have this negative that we have to get rid of. So in the same way that you would have negative x is equal to 6, and you divide by negative 1 on both sides so that those negatives cancel, you're going to do the same thing here. You have to get rid of that negative. So in order to do that, you're going to divide both sides by negative 1. Now, several important things happen here. First, that negative cancels out. Okay, it becomes a positive. So you're left with a positive absolute value here. The second thing that's going to change, remember the rule, whenever you divide by a negative number, your inequality sign is going to change. So it becomes a greater than. You have to, or less than sign, sorry. You have to flip it. The next thing that it's going to change that's important here is that this negative side over here, negative divided by a negative, is actually going to become a positive, which is important because now we have a true statement. Okay, we've solved for this. So for step 2, when we have to check for the true statements, is a positive or can a positive be less than a positive? Yes, you can. So you know you can continue forward. Many of you will see this and you'll tell me that it's no solution, which is incorrect. So you always need to go through and solve it. Now step 3 is to write your inequality sign, or your new inequalities, 1 positive and 1 negative. Your positive stays the same, x plus 1 less than 6, x plus 1 greater than negative 6. Your sign changes, and you flip the inequality and your sign changes. So then you can go ahead and minus 1 on each side. X is less than 5, or minus 1 over here. X is greater than negative 7. So if you wanted to plot these, you have 5, open circle, less than is going to be this way. Negative 7, x is greater than negative 7, open circle this way. So these two are actually going to connect. Okay, and those are your solution sets. All right, guys, I know this video was long. Make sure that you have the steps down here, your practice problems for this section. Shoot me a reminder if you have any questions.